Okay, now we're going to take a look at creating some attributes to bring into the .NET. So first, we'll start with this attraction weight. Okay, so you can see the name there of the parameter attraction weight. We can generate that outside and have, make some noise, apply some noise to it. So get an attribute noise is the easiest way to do this. So by default, that's doing a color, which is not what I want. So we want a float. The name is attraction weight. Okay. So obviously the spelling and no gaps, it has to be like this. Let's visualize it. So we press that I and then click on that, and it will create a visualizer for us. And let's take a look at the geometry spreadsheet as well. Maybe if we split this, right click and go to inspectors, geometry spreadsheets, we can see them both at the same time. We've got the attraction weight. So there's going between 0.2 and 0.7. I'm going to set this to 0 centered values. So there I've got minus values now. I'm also going to turn off this raw value. I just find that gives us, see, it goes from minus 1 to 1 now pretty much. I don't want minus numbers, so if I set this minimum to 0, okay. Let's see what else. I want to remap this as well, and I'm going to turn the element size down 0.1, something like that. Good. So the white, I think, well, we can double check. Oops. Yeah, so blue will be, the particles will be allowed to move, and white will be sticky. They'll stick together in clumps. We can change this. This is auto, so we can change it to min and max, 0 to 1. I don't see why. We should have some red values since we've got... Oh no, now they're going, I think because of this ramp. Yeah, so if we play around with this ramp now, I want to have more of the white, so I can bring that over and set this maybe to 0.6. Oh, I've set the element size to 0.6. 0.1 there. I want to change this to 0.6 for the location. There we go. I want to have a little bit of clumping in the low, in the white areas, in the blue areas as well. So we'll just set that to like 0.2 or something. 0.2 or 0.15. Just a little bit, so they're not completely free to kind of roam around. And a bit more roughness as well. So going to fractal. These will look more interesting, the more resolution we've got, the smaller the grains are. But I'll give it some more roughness now. Okay, so you can see that's a bit more interesting. Cool, and that should just work. We watch that now. Okay, yeah, so you see, I'll let that play through a bit. We're bringing out the ground plane here, so if we just press velum, so that we're merging out just the velum object and not the ground plane as well. I'm just going to play that a bit and press spacebar and F, and we should see, yeah, so you can see the white bits are clumping together, and then the blue a bit more separate. Just gives you a bit more of an interesting surface. It's a bit hard to see, to analyze this. One thing you can do, is to do a copy to point. When you're working in low resolution, it can be useful to do this. Use these as your points, and let's just see how many points we've got. 90,000 should be okay. Drop a sphere. Plug that in there. And give yourself some kind of light. We'll do a skylight. Okay, and hide that. We don't want to see these. Let's just do a grid for the floor. I'll just make that big. Okay, and just see, this should help us get a sense of the, the shapes that we're getting. Okay, let me have, I don't want to crash this. There we go, something like that. I might get rid of the skylights. There we go, just so we have a distant light. And that's angry because of this, and just delete the channels there. Maybe something like that. Cool. Okay, so yeah, that should help with visualizing the kind of shapes that we get. Cool. So let's go back inside, back up here. So another thing we can do is set something called, I'm going to create a couple of attributes up here. And these attributes are not currently within the solver, but they can be read by the solver. So I'm going to do one called pin to animation. The point and the size with the value is going to be 1 to start with, and then we'll do another which will be a value of 1 also, and that will be called stopped. Okay, so this pin to animation won't do anything yet because we don't have any animation on our points coming in. We will do, obviously we'll bring this animation back in a little later. But that's just generated this pin to animation. I don't know if they should be an integer actually. We'll see. Hopefully, we might need to come back to change that. So they're basically just 1 or 0 on off. So pin to animation means follow the animation. Stopped means don't simulate, right? So they'll either be static or animated if they're following this. Okay, I don't want to 3 there. I don't know why that's there. So they're both set to 1 now, and we can use this basically to set, it's like in if you've done some RBD stuff, to set them either to active or inactive, or with particles I think it's the same, active or inactive, or changing the mass, so let's drop in attribute VOP. Okay, and then here we'll control those values. So first I'm going to take a relative bounding box. Okay, and this needs our current position of each point, and file will be op input 1. If you remember that op input expression is kind of the same thing as just this input, take that geometry. So that's giving us a bounding box of this. We want to just take the y components of that, so we take a vector to float, plug that in there, so that gives us the position in y. Okay, and then I want to compare that. If I take x, y, okay, this with another value which we will animate. So if I middle mouse button and click promote parameter, and that will give me a result which I don't want to go into any of these. I want that to go into sorry, I don't want equals, I want less than. Okay, and that will give me a value of 1 or 0, which we can use to drive our pin. Sorry, am I doing? We need a bind. Bind export. Because we don't have the attributes here, we generate our own export. We plug that in there, and this will be the stopped, which is also an integer, and another one here, which will be the pin to animation. Yeah, that just needs one end. Okay, and let's visualize those attributes. So if we Okay, and so this is that input. So we're comparing the value, the height with our value here. And then if we change this, we should see we get that. So what I'll do is leave that like halfway, and fingers crossed, without having to do anything, that should be read by our simulation. Yeah, and you can see the bottom part is static. And once we bring in that animation again, that will be animated as well. And what we'll do later is animate this value as well. So that's a viewport error there, I think. Yeah, so just had a Houdini crash there. So if that happens, just go to File. You can try this. This is something new. I'm not really sure how it works. Let's see. Yeah, that's the thing we just did. And that is the current time. I'm wondering if they will save it. Yeah. There we go. So it looks like it used to be that your hip, yeah, this would be, oh cool, there we go. So it's recovered there. So yeah, it used to be that when it crashed, you go to File, Open, go into Temp, and you'd have it here. But the kind of root, if you had things saved in your using the hip file, the hip variable, then it would kind of be messed up and you'd have to save it back into your project. But now that new thing there, open, what was it? Open crash recovery. So that's kind of, I think that was in 2018. 2018, sorry, Houdini 18. But anyway, yeah, we've got that working. Go back to the start. I'll save it in case that happens again. And next, I think we'll look at the animation.